this video I am going to explain you about one of the topic of mathematical method of physics, that is matrices. Before going to start, if you are new to my channel, please subscribe my channel for upcoming videos. So let us start. Matrices. First of all, we should discuss about the definition, and then we can discuss about order of matrices and what are the types of matrix. So first, if we want to define the matrix, it is a rectangular array of m cross n numbers, real or complex, in the form of m horizontal lines called rows, n vertical lines called columns. It is called matrix of order m by n. Such an array is enclosed by square bracket or round bracket or the determinant, and m cross n matrix is usually written as, let us take any of the alphabet. A equal to, it is in the square bracket. These are what elements of the matrices. So it is what m cross n matrix. In brief, the above matrix is represented by A equal to bracket of A I J m cross n. So the number A1, A2 are known as elements of matrix A. Aij belongs to ith row and jth column. So here 1 is first row and first column, 1 2 is first row and second column. That is called I comma jth element of the matrix. A is equal to bracket of Aij. This is the definition for matrix. Order of matrix. A matrix which has m rows, n columns is called matrix of order m cross n. The order of the, for example, this is the matrix of 2 cross 3, that means 2 rows and 3 columns. So this is what the order of matrix. So what are the types of matrices? So the first one, that is row matrix. A matrix having only one row is called row matrix. That is denoted by, usually generally we can represent matrix as capital A is equal to square bracket of Aij into m cross n. Aij, A is what element of the matrices, ith row, jth column. M cross n, that is order of the matrix, is a row matrix if m equal to, so m is equal to 1, that is having the single row, which we call row matrix, having the columns 4. So that is 1 cross 4 is the order of the matrix. Column matrix, a matrix having only one column is called column matrix. And for example, if n equal to 1, that is what having one column and 4 rows, order is 4 cross 1. Zero or null matrix. If a matrix having the elements which are equal to 0, then it is called zero matrix, which is denoted by 0. Thus here the example, this is what 2 cross 3 matrix, all the elements are going to be 0. This is equal to here 2 columns and 3 rows, 3 cross 2 matrix. This is 3 cross 3 null matrix. Singleton matrix. If in a matrix there is only one element, then such type of matrices we call single matrix. N equal to 1 or m equal to 1. Only one row, one column. Horizontal matrix. A matrix of order m cross n is called horizontal matrix. Means n must be greater than m. columns must be greater than rows. Vertical matrix, a matrix of m cross n is vertical matrix if it has rows more than columns, m greater than n. Square matrix, if the number of rows and number of columns are equal, then it is called square matrix. So in this you can see 3 rows and 3 columns, 3 cross 3 matrix. If you want to define trace of matrix, so that is only for square matrix we can define. Sum of diagonal elements of the square matrix we call trace. So we can discuss further. Diagonal matrix, as the name indicates, all the elements expect the principal diagonal in square matrix are 0. The diagonal matrix if Aij equal to 0. And here I, rows and columns, if we take I is not equal to j, is a diagonal matrix of order 3 cross 3. Then we can denote diagonal as 2, 3, 4, the numbers. Scalar matrix, if all the elements in the diagonal of diagonal matrix are equal, it is called scalar matrix. Thus we can define with the example here, and element Aij is equal to 0 if I is not equal to j, if I is equal to j. K is what? Constant. Example is 3 cross 3 scalar matrix which the diagonal elements all are same. Unit matrix, if all the elements of the principal diagonal are 1, then such type of matrix we call unit matrix. Triangular matrix, a square matrix is said to be triangle matrix if the elements above or below principal diagonal are 0. There are two types, upper triangular matrix and lower triangular matrix. Upper triangular matrix is in a square matrix, the above the diagonal elements are non-zero. This is upper triangular, and square matrix is called lower triangular if Aij equal to 0 when I is less than j. Here opposite, I is greater than j. Singular matrix, a matrix A is said to be singular if the determinant A is equal to 0, otherwise non-singular. A is equal to determinant A is equal to 0, singular. Determinant A is not equal to 0, non-singular. Symmetric and skew symmetric matrix. Many of the questions have been asked in exam on this topic. So here square matrix is called skew symmetric matrix. Symmetric matrix if Aij is equal to Aj for all ith and jth column. For example, here you have 3 cross 3 matrix. You can see the except diagonal elements above and below are having the same numbers. Symmetric because A12 is equal to 2A21. Here 2 and this 2 is equal. So A31 is equal to 3, A13. So above and below diagonal elements are same here. Symmetric matrix. Q symmetric matrix, square matrix, and this thing you should remember for symmetric matrix. Aij equal to Agi. Q symmetric matrix is a matrix in which Aij is equal to minus Ji for all values of I comma j. So here is the example. Except diagonal elements, if you take above and below diagonal elements, they are same but opposite in sign. That is Aij equal to minus Aj. Here this is 2 cross 2 matrix. And one more thing, in skew symmetric matrix all diagonal elements are 0. Hermitian and skew Hermitian matrix. So like symmetric and skew symmetric, how we defined here Hermitian. Square matrix A equal to Aij is said to be Hermitian matrix if Aij is equal to Aj bar. For I comma j, that is A is equal to A transpose. So here the example for Hermitian. This is 2 cross 2 matrix. The diagonal elements above and below, if we take, they are same but they are imaginary numbers, complex numbers we can say. B plus IC, here B minus IC. Here this is 3 cross 3 matrix which having the complex numbers but opposite in sign, above and below diagonal elements. This is the skew. This is Hermitian matrix Aij equal to Aj bar. Skew Hermitian, if we take Aij equal to minus Aj bar for skew Hermitian matrix definition. So trace of the matrix, as I said, it is the sum of the diagonal elements, and some of the rules you should remember for trace of the matrix. First one, trace of lambda A is equal to lambda trace A. Lambda is what eigenvalue. Trace of A plus B is equal to trace of A plus trace of B, like that, trace of AB. Here lambda is a scalar. So transpose of a matrix. The matrix obtained from a given matrix A by changing its rows into columns is called transpose of the matrix A, and it is denoted by A cap T or A prime. From the definition, it is obvious that if order of A is m cross n, then the order of A transpose becomes n cross m. That is, rows and columns are going to be changed. Here 2 cross 3 matrix, if we write transpose of this, it is 3 cross 2. So some of the properties of transpose matrix are given here. Just read about them. A transpose of transpose is equal to A. Like that, A plus or minus B transpose, AB transpose, KA transpose. So here the properties of the transpose. So these all are what different types of matrices. Especially you need to read about the skew Hermitian matrix, symmetric, skew symmetric matrix, transpose, trace of the matrix, and other different types of matrix definition, order of the matrix. So I hope this video is helpful for you, and in the next video I am going to solve problems related to these types of matrix.